Hi guys, it's Mrs. Elhofer, and I was talking to Miss Davis about the Light and Optics packet, and I wanted to go over a few of the things that you're going to need on the front of your packet. Your new packet, which she handed out to you this last week, was due November 8th, which is a Friday, just so you know. So your next test is probably actually going to be more like a quest. If we feel like we need a little bit more time, I can definitely give you more time on this unit because November 8th is a Friday. It's a shorter test that you're going to be taking because it's a shorter class period, okay? Before we get started with the equations and the variables that you're going to need for some of this packet, I just want to remind you that even though I am gone on maternity leave, it doesn't mean that you're just, sink or swim all by yourself. However, it is time for you to use the things that I've already taught you to figure some things out for yourself first. I do want you to try these things without my support right away because you've had a lot of help so far, and some of these math problems and things like that are actually not going to be that difficult algebra wise, okay? So it is time for you to take off the floaties and dive into the deep end of the pool yourself. But like I said, if you have questions on the packet and things that you want to see done, which I'm going to guess you probably want to see the very first question done, which is fine. We can do that together today. All you have to do is ask, okay? Talk to Miss Davis, tell her, we need this question. I'd really like to see this one done on the screen, and she can tell me. I can make the video real quick and send it over, okay? Just be patient and breathe through it. Don't get too anxious and stuff like that. I am still here with you, but you actually have a lot of the skills that you need to be successful in this packet already. All right, enough of that. Let's just go ahead and move forward. So the equations we're going to be using are still similar equations from the wave and sound unit. So the equations from the wave and sound unit that we're going to copy from before are the frequency and the period equations, okay? So the first one was the period equation. The period of a wave, remember, is represented by the letter capital T, and that is going to be time per cycle. How long it takes one cycle to occur, okay? Over here in variables, we'll put that capital T stands for period, and don't forget that we measure that in seconds. Then we also have the frequency equation from before. And if you recall, period and frequency are inversely related. So frequency, lowercase f, is number of cycles per second. So we just flip the fraction upside down. That's the inverse. Lowercase f stands for frequency. And remember, this is measured in hertz. You may hear Colt in the background fussing. He's trying to go down for a nap, so I will stop the video if he fusses too much. So frequency is measured in hertz, and that was that German physicist who came up with the equation for frequency. And then we have the relationship. We might have written this a little bit different on our last one. Relationship between T and F. And remember, period is the inverse of frequency, or frequency is the inverse of period. So if you have one or the other, you can always flip-flop in between, okay? Nothing new here. This is all from our last unit. Now, because light is a wave and a particle, we're going to be using the wave equation for speed, but light is special. So sound, we didn't really talk specifically about the speed of sound, because the speed of sound does change pretty frequently depending on what medium it's traveling through. However, light doesn't need a medium, and even though light speed does change, most of the time we do talk about the speed of light in a vacuum. So we're going to do speed of light equation. And excuse my handwriting is a little sloppy today. Speed of light equation. Now it is literally the same equation as the speed of a wave, which we had before, which was v equals lambda times f. But because we're talking specifically about light, we actually use a different variable. I know, it's so silly, and physicists just like to make things a little bit more complicated or look a little bit more complicated. It's not complicated at all, okay? We're going to use the lowercase letter c instead of v. We still have lambda and we still have frequency, okay? It is the exact same equation from our previous unit, v equals lambda times f. But this time, c is actually the speed of light. Okay, sorry, I had to step away for a minute. So, back to what I was saying. C, lowercase letter c, is the variable that we use for specifically the speed of light. We usually use the lowercase letter v when we're talking about speed or velocity, but because light has a certain speed, and this speed happens to be, excuse me, 3 times 10 to the 8th meters per second. This number right here, you're going to use over and over and over again whenever you're talking about the speed of light. So this is a known speed. This is going to be a constant whenever you're doing any problems that tell you, oh, you know, light is traveling through a vacuum or through air, and this is for vacuums and air, okay? When light travels through different solids, which we're going to get to towards the end of this unit, when it starts traveling through diamonds, Pyrex glass, plastic, different things like that, it actually slows down. It's going to change speed. But for all purposes of the very beginning of this packet, we're going to be using this number for the speed of light. Okay. Now, the times 10 to the 8th meters per second means this is a really big number. And the wavelengths for light are actually really small numbers. So I just want to point out that you're going to have to use your gold sheets, the backside of your gold sheets. But I am going to put a little cheat right here. Okay. Oftentimes our lambda, our wavelength, is going to be measured in nanometers. So 1 times 10 to the 9th nanometers is equal to 1 meter. So it's 1 times 10 to the 9th nanometers is 1 meter. You're going to need that often when you're plugging in your numbers for this equation for speed of light, because they're going to give you the wavelength in nanometers, and you have to convert that to meters first using that picket fence method that we've done before. Okay, the last equation that we're going to go over for right now is actually an equation we learned in the very beginning of our first unit, but this is just going to be our general speed equation. The general speed equation. So we do have speed of light, which is over here. Oh, I'm so sorry. I forgot. Lambda. I was just remembering that we already had these from last time. Okay, lambda is wavelength. It is going to come in nanometers, but it needs to be in meters, okay? So that's the unit that we need to use for wavelength. All right, I apologize. So back to it. General speed equation. So our speed of light equation is one that we're going to use very often, but sometimes, like in the very first question that we'll go over, the speed equation, V equals D over T. We talked about this a while ago, but this one is a concept. It's a conceptual equation because we know if we travel a certain distance in a certain amount of time, you divide those two numbers, you're going to find your speed or your velocity. So V standing for velocity or speed, and we still measure that in meters per second, nothing new there. D is still distance. Again, needs to be measured in meters. And T with the little tail, remember we do it with the tail so that it doesn't look like a plus sign, is time, measured in seconds. Okay, so these equations are the ones that we're going to be using for this packet so far. There is one more equation. I'm not going to go over it today because I don't want it to go too far ahead to where you don't understand what I'm talking about, but these are going to be the equations we're going to use for right now for the beginning of the packet. Remember, I gave you the answers in the packet so that when you're working through the problems, you're trying it yourself. If you don't get the same answer as me, then try a different way. Try a different equation. You need to look at the variables that you're given. Make sure you're making your given and find t-chart every time. And then if you get stuck, get up out of your seat, go find someone new in the class and see if they figured it out. Remember, physics is a team sport, so I want you guys up and about, moving around, asking for some help from people who may have already solved the problem, okay? I'm going to go over in a separate video question 1.1.